So next up is exponential equations. An exponential equation is an equation that contains a variable in the exponent. Some examples are 2 raised to the exponent x equals 32, 9 raised to the exponent x plus 1 equals 27 to the exponent x, or 1 equals 100 times a half to the exponent of x over 3. If an exponential can be written as powers of the same base, then the following property may be used. So if a to the exponent m equals a to the exponent n, notice the bases are the same, then we can drop the base and we can say that m is equal to n. The two exponents must be the same if the bases are the same. For example, if you're given 4 to the exponent of x equals 4 to the exponent of 3, notice the bases are the same, so therefore this x must equal 3. The exponents must be equal. Therefore, x equals 3. So let's go through a few examples. So example 1. Right away we see the bases are the same. 5 to the exponent x equals 5 to the exponent 6. So we can drop the base and we end up with x equal to 6. In example B, we notice the bases are not the same. So what we're going to do is we're going to rewrite 32 as a base 2 number. And why do we do that? Well, first of all, we want the bases to be the same. At this point, you're going to need to guess and check. So 2 to something is equal to 32. So all we do is guess and check some numbers. So if you try 2 to the exponent 5, that's equal to 32. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, and then the next one is 32. So I'm going to rewrite this expression. I get 2 to the x equals 2 to the exponent 5, because again, 2 to the exponent 5 equals 32. Now since the bases are equal, then the exponents must be equal. So therefore, x is equal to 5. So same idea. I have 7 raised to the exponent of 3x minus 4 equals 49. So I'm going to rewrite 49 as a base 7 number. So recall that 7 times 7 equals 49. So I get that 7 raised to the power of 3x minus 4 is equal to 7 squared, because 7 squared is 49. Now that the bases are the same, I can drop the base, and I get 3x minus 4 is equal to 2, since the exponents must be the same. And the next part is to solve for x. So I'm going to add 4 to both sides, and this gives me that 3x is equal to 6. Then I'm going to divide both sides by 3, and we're left with x is equal to 2. So again, to solve these types of problems, make sure the bases on both sides of the equal sign are equal, and then you just solve for the exponents. So let's do one more. We have 3 to the exponent of 5x minus 8 equals 27x. Again, the bigger number is 27, so I'm going to rewrite 27 as a base 3 number. And there you'd have to guess and check. So 27, 3 squared is 9, 3 cubed equals 27. So this means now I have 3 to the exponent of 5x minus 8 is equal to 27 to the exponent x. Remember, we are rewriting 27 as a base 3. So we put in 3 cubed where the 27 is. For this part here, we need a power of a power rule, because it's an exponent raised to exponent. So we get 3 to the exponent 5x minus 8 is equal to 3 to the 3x. The power of the power rule states we multiply the two exponents. So here we use the power of a power rule. Now that the bases are the same, we can drop the bases and set the exponents equal to each other. So we get 5x minus 8 is equal to 3x. I need to get the 3x off from the right side. So I'm going to minus 3x from both sides. And I get 2x minus 8 equals 0. I'm going to add 8 to both sides to get the number to the right side. So I end up with 2x is equal to 8. And the last step is to divide both sides by 2. So I end up with x is equal to 4. So once again, make sure that both sides have powers of the same base. Simplify where needed, and then you can drop the base and then set the exponents equal to each other. All right, next type of example. Solve for x, and we're going to verify using Desmos. So notice in this one, I have 2 to the x on the left side, and I have 7 on the other. So I need to rewrite 7 as a base 2 number. The problem with 7 is, if I look at 2 squared, that's equal to 4. That's too small. But then if I look at 2 cubed, that's equal to 8. That's too big. So that means I need something in between 2 squared and 2 to the exponent of 3. And you could try 2 to the exponent of 2.5, and you can keep on trying numbers. So 2 to the something has to equal 7. So for us, the way we're going to find this number is to use Desmos. We're going to graph 2 to the x and graph 7. So what I mean is we're going to graph y equals 2 to the x, and we're going to graph the line y equals 7 and find out where these two meet. What is their point of intersection? So we go to Desmos. So in Desmos I hit y equals 2, hit our exponent button, and then hit x. And there's our graph of y equals 2 to the x. And then I'm going to compare it to y equals 7. And then hit enter. Next, all I have to do is click on the point of intersection. And you see that the exponent that works is 2.807. So that's the intersection, or the x value that we're looking for. So again, from Desmos, we get x is equal to 2.807. And what we can do is we can check our work. So this is the answer. And if we want to check this or verify, algebraically, all we have to do is take 2, raise it to the exponent of 2.807, and see what answer we get. And on my calculator, I get 6.998, and so on. So it's very close to 7. Remember, we're approximating this answer. And when you're using your calculator, you would type in the number 2. You'd find your exponent key, which might be this symbol here or this symbol here. And then you type in 2.807 and your equal or enter sign. All right, let's try the next one. The next one's a little bit more complex. But the first step is to get a number on the other side. So I'm going to add the decimal 0.15 to both sides. And I end up with 1/2 to the exponent x is equal to 0.015. So I need to solve for the point of intersection of y equals 1/2 x and y equals 0.015. So the x value of that point of intersection is the value that we're looking for. So again, let's go back to Desmos. So I go back to here. So I want 1/2 x, so I can use my brackets. Do 1 divided by 2. Hit the right arrow, close the bracket, hit my exponent button, and then hit X. So there's our new graph. And then I want my y value this time to be 0.015. There it is over here. So this one's a little bit trickier to find because the values are so close. But notice if I tap on the green graph, it pulls up some points. And the second point you can see is the point of intersection because I have decimal 0.15 for my y value, but I have 6.059 for my x. So 6.059 is what we're saying it should be. And again, we can verify this. So let's verify and check. So we verify, we take 1/2 in our calculator, put brackets around it, and type in the number 6.059, and hopefully that gets us close to decimal 0.15. And I ended up with 0.014998 and so on. So definitely very close to decimal 0.15. For question 13, you'll need decimals.